Hi, and welcome back to part 2 of my brief video on testing a theorem prover using the StarExec framework. So I've let it run for a while, actually overnight, and we've got some results here. So it looks like the majority of the tests have completed. And a note here that a lot of these tests are very hard. In fact, there are quite a large number that no major theorem prover solves at all. There can be even some open problems in mathematics here. So this is actually a pretty good result. So let's take a look now at what the results are. So we can click on this little square here and see how the prover actually did. So we've got summaries that are available in all of the subspaces. So let's just look at one of them. So let's look at the puzzle subspace. So you can see that the JavaRes prover ran and it solved a number of the problems. It took a certain amount of time, and we could go through in sort of in more detail if we download all the results and see the output. So in fact, that's what I'm going to do. So what I'm going to do here is get the job output. There are some other options. I actually don't use most of them. This is the one that I want because I can get the job output for each individual problem, including getting a proof. So we've just downloaded the zip file of results, and this is job 1667. So we just get an increment in the job number every time we try to run. And it mirrors the directory structure that we already set up for the TPT problem set. So we get the set of problems beneath it, all the same categories. Let's just take a look at an easy sample. Under each problem set, then we have the particular prover that was used. So you can run a set of different provers to compare them if you want to, but this time we just ran JavaRes. And let's take a look at just puzzle 1, and beneath each puzzle, because there are multiple provers, you can have multiple answers, but we just get one output file. So let's take a look at that. Here we get some information about the problem itself. This is the problem that was running, puz 001 plus 1. It's in TPTP version 7.4. We are shown the command that executed in either towards the end or in a future video. I'll tell you a little bit about how to configure a system to run under the StarExec framework, but basically you need to give it a script, and then it will iterate through sending all of the different problem files to the command or the script that you provide for it. You get a little information about what cluster it was used on, how long it was allowed to run, and then we get the output of the actual prover. So in my code, I have it print out the name of the thing it's running on and all the options that are used. We'll also talk about some of these options and optimizations in a future video, what they mean, talk about subsumption and indexing and various things of that sort. We've got a couple of characteristics here of the problem. It does have a conjecture or a question that's being asked. You can also run a problem that doesn't have a conjecture in it, where you're really just trying to prove, are the axioms consistent or are they contradictory? That's a really valuable thing to know. But also valuable to know is to be able to ask a specific question. Is something true, something specific true within this set of knowledge that I have? And we also find out that it's first order logic, so it's not just clausal form. So we've actually got to convert, as I mentioned in one of my prior videos, there's an approach for converting the first order form to conjunctive normal form, and this tells you whether that sort of process had to happen. And then we have a particular strategy for picking which axiom in the set of axioms to try yet. So it's basically a loop or a search, going through all the axioms, trying to see, do they resolve or combine with other axioms to reach new conclusions. And you cycle on that process, as I mentioned in my video on resolution, until you either get an answer or you run out of things to try. And so here, this is the method by which, or is some indication of the method by which we're going to try to make that selection. Right here, we can see, here's the actual proof. So we converted everything into conjunctive normal form, and we get a proof. And this is a sort of Agatha Christie mystery problem. It's really easy. It's really brief. This is really one of the easier problems. And we get the result theorem here, which tells us that, in fact, we had a contradictory set. So we did get a conclusion. We got false. If you can see that highlighted here in the last step. And it was really easy. It took only 8 milliseconds to compute this. So at times I've run across people that say, oh, first order logic, that's really much too slow. Well, it's not. It depends upon the problem. If you're comparing it, first order logic problems that are easy to problems in other forms that are easy or small, like graphs or description logics, then it's also easy. If you get a very large problem set, a very complicated question that you're trying to ask, a very complicated theory, it's going to take longer. But the fact is that a lot of problems, even in very large axiom sets, as we've shown in some prior papers, are really fast, under a second to solve them. Certainly plenty fast enough to be practical in solving practical question answering problems on the internet. All right, so this is the sort of result we get. And in my scoring, I just look to see whether the expected output, the expected sort of tag or answer tag of the problem in the TPTP repository is the same as the one my theorem prover comes up with. So I have another routine that just sort of cycles through all of those and gives me a score. And if I take a look at that score and look at some of the details, then I can see how well, or have an indication of how well my theorem prover is functioning. All right, so I hope this gives you some idea of how we go about testing theorem provers, at least first-order theorem provers, using the StarExec framework and the TPTP problem set. Thanks for watching.